Hey everybody, it's Dr. Schulman. I just finished doing all the geometry videos and we're about to go into data, probability, and measures of center. So there's not a lot here, but I really try to build it up. I made the quizzes extra long, try not to hate me too much for it, but I wanted to give you like all the different ways that you can represent data, show data, do all of these things. So hopefully you find this interesting. We're gonna jump right into it. I usually do like little lessons and things like that. I'll probably do that. I'll probably add stuff to the next one, but measures the center is pretty straightforward. So I'm gonna share my screen and I'm gonna go right into. I want to go. I want to have Delta open. And I also want to have. Sorry, I was creating all the statistics work. Uh, Come on. Sorry about the pause. So here we go. I hope you find this interesting, but we'll see how it goes. So we're starting not with data, we're starting with measures of center. Now, I think this is like the best way you can get your students started, right? I think this is the best stuff you can do. I said I wasn't going to share some lessons, but maybe I will anyway. The best thing you can do for finding measures of center. Well, what are measures of center, right? So measures of center, that's mean, median, mode. And that's different from measures of spread here. So I have some more room. So we're math for teachers and data. And that's different. So this is center. This is basically the central tendencies, like how the middle of the graphs look. And that's different from stuff like variations. And this is like it's how spread out the data is. And that is range, standard deviation, and variance. So this is just trying to see how the middle of the data works. What is mean? It's the average. What is median? It's the middle. And there's a little formula for it. It's always n plus 1 divided by 2. We'll always tell you that middle term, so you don't have to just like cross out from your numbers. And the mode is the most. Um, I think probably the best ways to teach these central tendencies. So this is just how the middle of the data looks. What is the middle of the data? And this is how spread out the data is. Okay, so that's the difference between a central tendency and what's called the spread or the variation. Okay. Um, Use your students for data. Use your students for data. Okay, what do I mean by that? Poll them. Have them be the numbers. We're talking about data. You could always get the mean, median, mode that way. So I think the best thing to do is to use polls for students, or have students come up with stuff. Students experiment, right? Either have them roll dice, have them play cards, have them flip coins. I also think showing like this gets messed up a lot, median mode. A really good way to think about it is tell students where it comes from. Median is like the prime meridian. So it's like a lot of times back in the day, they were trying to find the middlemost route when they were going on journeys. Mode, that's Thucydides. He helped the Greeks win the Peloponnesian War by figuring out which brick was the most as they went around their structures, and that's how they built their ladders. And the mean has a bunch of different origins, but we'll look at that later. So I said I was going to give you some lessons, but I think the best way to show you how to do this is just give you some stuff. So let's look at a stats final project. This is an easy one. So I'm gonna put a bunch of these in. So this is a really easy one for students. I did this for a final project for one of my students. So they actually had to do an experiment or an observation. What brand of cookie has the most chocolate chips? Does buying the large French fry container justify the higher cost, not larger cost? Sorry about that. Obviously, I made these. That's why they're not the best. Our self-checkout's actually faster. And then you could do this questionnaire surveys. Who wears more jeans? Who athletes at the school I was at have higher GPAs? is exercise related to one's mood. So they had to do a submission form, which was cool. So name of the topic, who's their population, quantitative, so that's their number data, grades, categorical data. In the form they had, I was approving each topic, make sure it was good, and gave them some help. How many people, so what's their sample, or how many cookies, right? Sample is just the amount of data. It's usually referred to as N. And then how will they show their data, which is a table, histogram, pie chart, box plot, scatter plot. Are they going to do typed, handwritten, or poster? And then students would do this. And here's one that's filled out for them. So this is one of these questionnaires. This left side is a sample for them. I made this back when I was at SHAP. So qualitative data. So I think it's just really good. So I had all this information, and then this was the data that I pulled for students. So students could see this. So black is athlete, gray is non-athlete. Then we've got the pie chart, and they had to show different ways of showing the data. So this I think is good for students. And I'll share this one. And I'll give you a couple more ways that we can do this. But I just think having your either, and then I want to show you like just pulling them for the data is really good. I'll give you like a couple of different examples right off the bat. So we're here. I was just going to do the problems, but I was like, I want to share a lot with you. So here's a final stats project. I also want to show you the, my God, what was it called? It was with roulette. Gambling game, was that it? Yeah, so this is this gambling game. So this was after I had them do a bunch of labs. And students had to come up with their own gambling game. It's like a modeling based idea using statistics and data and probability. So then they wanted to search their next game to keep people excited about visiting our great state. With increases in tourism traffic, new and exciting tabletop card, dice slot, or virtual games are needed to meet the demands. You and your team are charged with developing a game that is engaging and fun to play, but extremely hard to win. So they want to make a new game, unlike others, or revise a current game. So it's got to be fun but hard. They had to name the game, describe what makes it fun, describe what makes it different from other games, explain why it's difficult to win, explain the directions of the game, provide a sample set of outcomes, calculate every probable outcome, provide the probabilities for situations that involve multiple steps. So they had to do compounds, conditional, or dependent. Then they had to write a letter, and then they had to do a whole presentation for it. So the gambling game was fun. If you think gambling is bad, you don't have to do it, obviously, but that's the gambling game. And this was after I had them do this entire gambling lab. I think it was called Gambling Lab. Well, I know it's in my project-based learning one. This is one of the ones you're going to get to see. So, oops. Here it is. And here's some pictures of one person's game. This girl did a really good job. She made a roulette, but it's harder to win because there's more colors, which is kind of cool. So I don't know, I just thought this one was good. So I took a picture of it. And notice how they're all outside my classroom so other people can play. Here's the labs. Yeah, so they first got to actually play. They got to play all these games, and that's what they did to find each probability and find all of their central tendencies. They got to learn how to play craps and all the probabilities for craps. They got to do the Monty Hall problem. They got to work with coins, dice, and cards. They got to do blackjack. There's roulette. And there was something at the end. There's Plinko. There was something at the end for them where they got to make one, the project, but I just thought mine would be way better. So I took this and I I just try to make it better. I got this from somewhere and I just thought I could make it better. Oh, sorry. So let's do nice. They spell gambling wrong? Oh yeah, what a surprise. Okay, so what's another thing that I've done? The whole idea I'm trying to share with you is just how we get students to use their own data. So a really good way I've done that is using Venn diagrams, and we'll talk more about that when we get to probability. But I'll share this Venn diagram one. I think this is it. Is this the one that's fun? Yeah. So at first I had students fill this out. So this is like their data. So how many like rock, rap, and country. It was just a really good way to have them understand like the ideas of probability from it. But like then we got to try some ourselves. Here are the answers if they're too hard, but this first one we built together. That's how we got the data for it. So um, there's tons of Venn diagram stuff. Blank ones you can fill in. I just think they're really useful for students. So, but I'll give you this set of slides. So I know that was a lot, right? Tons of stuff. So I'll just call this Venn diagram. Oh, sorry. I'll just call this Venn diagrams. So it's not super long. And the last one, which you've already seen, is the lyric one. And I've used the lyric one in almost every class I've taught because students love music. And anytime I have to teach statistics, I always just use this one. I talk about where the median comes from, the mean comes from. So what is it? The mean, known by the Greeks, was not generalized to more than values by Simon Stevin. This method was first used by Tycho Brahe to reduce errors in the estimation of celestial bodies in astronomy research. So yeah, I knew there was a bunch of different places for mean. There's the moda for the height of bricks, and there's the navigation for where median comes from. And for this one, they just get to pick their songs and figure out the mean of them and the standard deviation, and then they get to convert all of their song speeds per minute to figure out beats per second, beats per millisecond, century, and light year. The reason why this one's so good, well, one, they get to use their own song, they get to hypothesize which one's better, and they get to do they get to show the data with box plots and histograms and all the stuff we're going to look at. I'll do a big box plot before the next video, like as the intro of the next video. But here, when they got to pick the song they liked the best and tap it out, not only are they using conversions and thinking, but they get to do light year. Now, light year is a distance, so there's no like true answer for how, the speed of light because it's real distance. So it really pushes students to think outside the box. Okay, so I'll stop boring you with all of my lessons, right? And instead, oops, edit, undo, and um, so these are all just options you can look at. All right, let's get into the problems. But I'll do a to start the next one, I'm gonna do a box plot and a two-way frequency table because that stuff is common and you'll need to see it. So let's get into it. And I'm gonna remind myself for 10. So I don't forget. So before I start 10, I gotta do a box plot, a really good box plot, and a two-way frequency table. And I'll give you materials for both of these. All right, so let's jump into this one. I'm going to do there's not a lot, see, way shorter than most of them. But I want to share so you're more than prepared for any sort of math you want to teach your students. All right, let's get into it. So here's the first one. What's our first skill? Interpreting a dot plot. So here's a dot plot. Nothing crazy about it. It's like kind of like frequency. What is the word frequency? In case you don't know, frequency is just the amount of time something happens. It's like the number of occurrences. I'm pretty sure that's the word that they want. So this means we have 2 goals. Dot plot number goes shows every game. So they scored 1 goal once. So they scored 1 goal 2 times. They scored 3 goals 2 times, and they scored 4 goals 1, 2, 3, 4, 5 times, and they scored 5 goals once. What was the highest number of goals scored? It's 5. Let's do a couple more of these just to get used to it. Ta-da. Let's do a new problem. And let's move my weird head. All right. The results of a survey where the number of students reported how many letters there are on their last names. How many students have a name that's shorter than 8 letters? So let's do it. 1, 2, 3, 4, 5, 6. Oh, sorry, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 students whose name is less than that many letters. And let's do one more. How many students brush their teeth less than 2.5 minutes? So it says less than, not less than or equal to. It's 2, 4, plus 3 is 7. So box plots are a really good way to get students like to understand. You can use quarters, you can use coins. It's just good. All right, let's move on. So now we have a histogram. All right, so here we go. Here's our fancy histogram. Now, basically, to make a histogram, what is it? A histogram is a bar chart, but all of the bars are pushed together. Notice how there's no space. And a lot of times you got to know like what graph to use. So if they say a line chart, that's a trend over time. If they say a bar chart, like if it's an actual bar chart, not a histogram, a bar chart is for comparisons. A pie chart or a circle chart is for out of a total. Out of a total. It's usually used for budgeting. We can do a scatter plot. A scatter plot, the relationship between 2 variables. Now, we have a histogram though, right? So this is a trend over time. This is comparisons. This is a pie chart. That's a scatter plot. But when do we use this histogram? It's when we just want to see amounts. So I'm going to build this one for us. We have 2 people at 0. So it's always like the range, the frequency. We're gonna go further because we're smart. We're gonna do relative frequency, and we'll also do cumulative frequency. Isn't that nice? So I'm obviously giving you more information, but let's learn. So the first one's the range of scores. The first one is 0. Oh God, that is the ugliest 0 I've ever drawn. All right, let's go with it. 0, 1, 2, 3, 4, 2, 3, 4, 5. Okay, how many zeros do we have? This is what the histogram's used for. We've got 2 zeros. How many ones do we have? We have 4 ones. How many twos do we have? We have 2 twos. We have 2 threes. We have 0 fours, and we have 1 5. So how many in total? How many total values do we have? How many goals scored, right? So it's 2 plus 4, which is 6. 8, 10, we have 11. Now, when they say relative frequency is just out of the total. Relative just means out of the total. So this would be 2 out of 11. And we'd simplify, but none of these can be simplified. 4 out of 11, because 11 is a prime number. 2 out of 11, 2 out of 11, 0 out of 11, and 1 out of 11. A lot of times they show the relative frequency as a what? Percentage. I guess I'll just have use this other calculator. All right. So 2 divided by 11 is 0.18 or 18%. So this is also 18%. This is 18%. This is 0%. We'll do 1 divided by 11. And I'm just moving the decimal over. This is 0.09%. So it's 0.09, so it's 1, 2, it's 9%. And 4 out of 11 should be everything left over. This is 36%. Now, if we add them, we should get very close to 100. So let's add them up. So we have 18 plus 36 plus 18 plus 18 plus 9. We're short by 1 because I didn't get real specific, but it should be about 100%. All right. Now, when they say the word cumulative, that means putting together, accumulate, cumulative, accumulate. So the first one is just, we got 2. And then we have 2 plus 4. So our next one is, so from 0 to 1, we have 6 goals. All right, now we have to add 2 more. So we're going to go 6 plus 2. Now we have 8 goals. Okay, now we have 8 plus 2, which is 10 goals. 10 plus 0 is 0 goals. And finally, 10 plus 1 is 11 goals. These will always match. This is the range of the frequency, the relative frequency, and the cumulative frequency. And that is how a histogram is built. So what do they want to know? What is the range of scores? So the range, when they say range, it is just the biggest or the maximum minus the minimum. So in our case, it's 5 minus 0, which is 5 goals. And we'll do a couple more of these just for the fun of it. What is the median? Okay, we got to find the middle. I told you we can use this formula, which is n plus 1 divided by 2. The first thing we have to do, we can write out all the numbers if we want. Here's the long way. All right, so it's 2. How many 4s do we have? We have 4 4s. We have 1 5. 1 6, 2 7s, 3 8s, no 9s, and 3 10s. Now, if they ask us for the mode, we'll do the mode first. We'll do all of them. We'll do the mean, median, mode, and range. We could also do the max and the min if we want. Right, I'll set up like this. So the first one, we'll do the minimum. What is the smallest number? It is 2. What is the max number? What's the biggest one? 10. So if I want my range, it's going to be 10 minus 2, which is 8. All right, now let's do the mode. Which one appears the most? It could be bimodal, 2 modes. It could be multimodal, 3 modes. But we have this one. 4, it's unimodal. Unimodal means 1. So unimodal means 1 mode. What number appears the most? It's 4. But let's say we didn't have 4 here. It'd be bimodal with 8 and 10. And let's say we didn't have 4, 8, or 10. It'd be trimodal with 2, 5, and 6. But our answer is just, it's unimodal with what? 4. Because we have 4 4s. All right, let's do the median. Now I'm going to use the formula first, n plus 1 divided by 2. Well, how many numbers we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 plus 1 divided by 2. What's 16 divided by 2? That is 8. That is the 8th term. 1, 2, 3, 4, 5, 6, 7, 8. It is 7. Our median is 7. Now, if we have 2 numbers, like it's between 6 and 7 and 6.5. You take the average. What's the super long way? You do this. Small, big, 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 and we're left with the middle. I like the formula. Okay, so we have one more to do, which is the mean. And the mean is the average, so it's the summation. That is what this E is. It stands for sigma. And it's all your terms. So we're going from 2 to 10. and we're just adding them up. So don't worry too much about the notation if that's strange, but this is sigma, which means we're summing them all. So you can, but this is the symbol for summing them all. This is the number you start with. This is the number you end with. And then we divide by n, which is the total. Well, we already know how many we have, right? What is our n? Our n is 15. So whatever we get, we're dividing by 15. And so we're just going to add them. So let's add our numbers. Obviously, I could show you standard deviation, everything else, whatever formulas you want to learn. 4 plus 4 plus 4 plus 4. And to do this faster, you can multiply. Plus 5 plus 6 plus 7 plus 7. And there's 3 eighths, right? And there's 3 tenths. Plus, how many sevens? Okay. Oh, I already have the 7 there. So it's plus 3 eighths, 8 plus 8 plus 8 plus 10 plus 10 plus 10. So we have a 97 divided by 15. So what is our mean? What is our average? It is 6.46. Now, because our median is bigger than our mean, it means that we are which way skewed? We are skewed to the right, which is negatively skewed. Don't worry about the skew. We'll talk about it later. But they just want the median. The median length name is 7. 7 letters. Ta-da! Oh, nice. So they did it that way too. I like it. All right, let's do one more. What is the most common interval? So what is the one that is the most common? They just want the mode, so it's 90 to 119. That's our mode. All right, let's do another one just for fun. How many students were surveyed? So they just want the total. So 3, 4, 5, 6, 8, 10. 10 plus 5 is 15. I did that fast. Ta-da. Cool. So that's everything you're going to need to know about a histogram. All right, let's keep it going. Oh, we get to make a frequency table. Nice. So here we go. This is the range. They don't have relative or cumulative. They just want the regular frequency. That's fine. So from 0 to 1, we have how many? Do they want us to drag them in, or they just want us to hit this? I guess they want us to drag it. Click the tally box to count them up. I'm just going to put them in. It says click the tally box. Oh, that's what they want us to do. Okay, so that's how they want us to do it. How many from 0 to 1 we have? This is why I always put them in order first. There's only one here. How many 2s to 3s? We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. At 5, you do the cross, so you don't get confused. From 4 to 5, we have 1, 2, 3, 4. And finally, oh, sorry, that's 8. And finally, we have 6 to 7. So that's 1, 2, 3, 4, 5, 6, 7, 8. We made it. Oh, I said 8. Nice. All right, let's do one more just for fun. All right, from 0 to 4. This is why it's so much better if you just organize it. Every time I see data, I always write them out from least to greatest. And then I cross them out one at a time. Because otherwise you're just gonna get confused. Because I have to scan 2, 2, 3, 4, 4, 4, 0, 0. Okay. 5 to 9. Is there none? Oh, there's a 6. Okay, 10 to 14. 1, 2, 3. That's 1. This is why it's better to teach them about the relative frequency where they can divide and the cumulative frequency that they can add them all. I'll do that one with this chart. 15 to 19. 1, 2. That's it. 20 to 24 is 1, 2, 3, 4, 5, 6. 25 to 29 is 1. I think it's just 1. Cool. Let's see if this is right before I have to do them all. Which one did I miss? 813271. 813261. Oh, I missed one. All right, well, we'll use their numbers to do it. So if we have 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, 25 to 29. These are our ranges. Then we have our frequency. So our frequency is 8, 1, 3, 2, 7, 1. Now, if they want relative frequency, we're going to be dividing this by 8, 10, 10. So that's 20, 12. So it's 22. 8 plus 1 is 9, 12, 14, 21. Yeah, it's 22. So all of these added together is 22. So this is 8 over 22, which is 4 over 11. I like the fractions, but everybody likes different things. That's 1 over 22. This is 3 over 22. 2 over 22 is 1 over 11. 7 over 22 and 1 over 22. So these are all the relative frequencies. They'll turn out to be 1 if you add them up. And then we have the cumulative, which means we're adding them all. So the first one is what? 8. 8 plus 1 is 9. 9 plus 3 is 12. 12 plus 2 is 14. 14 plus 7 is 21. And look, we ended at 22. We'll leave it. Okay, so that was a lot. Let's find some means and medians. All right, find the middle number. Let's put in order first. 6, 8, 6, 8, 16, 20, 37, and 48. So let's do all of these first. So the min is 6, the max is 48. The range is 42. What's the mode? No mode, none. Or you could put NA, or you could put does not exist, or you could put a 0 through a line through it. They all mean none. Now let's get the median. I like doing the formula, but you can count n plus 1 divided by 2. So it's 6. 6 plus 1 divided by 2. 7 divided by 2 is 3.5. So between 3 and 4. What's halfway between 60 and 20? Our median is 18. To get our mean, all we do is we add them all up. That's the summation over n. There's my sigma. Just want to make it look like a Greek symbol. Our n is 6. So I'm just going to add them all up and divide by 6. So 6 plus 8 plus 16 plus 20 plus 37 plus 48. We divide this by 6. 22.5. So our final answer is 22.5. Beautiful, beautiful. All right, we don't have to do another one of those. All right, let's create a histogram. Oh, that's kind of what we just did. All right. So where do we get to drag? All right, so the first one is 5. All right, you wanted 2 boxes. Label. The first one is 0 to 4. Nice. 0 to 4, we have 5 students. And then we have the next one, which is 70. I'm trying. Have to start at the bottom. go up to 70. Cool, and this is 5 to 9. All right, and now we've got 10 to 14 is 65, so we got to go. I know, I'm trying my best. I'm just going to start up here, maybe it'll work easier. Oh yeah, that's where they want us to start from. So hard to do, okay. So here's 65, which is 10 to 14. And here's the final one, which is just 5. If I zoom in, nice. 15 to 19. Well, I'm definitely not doing that again. And here is our histogram. It looks great. Let's submit it. Beautiful. Oh, we could have gone as many that's why it would have been easier. So they want us to spread this out, which is fun. As long as they're the same width, you're good. All right, let's find the mean graphically. Let's see what we got. Find the mean graphically. What is the sum of these two numbers? It is 10. What is the average value? I don't know, 5. Type the points. All right, so here's 2. Here's 8. That's cool. What else do we have to do? Spread out the values into even stacks. What? Oh, okay. Ah, and they match when they're 5. This is a really great way to show it. I'm always impressed by this program. All right, so what is the sum? 4 plus 1 is 5. 5 plus 7 is 12. Well, what is the average value? 12 divided by 3 is 4. All right, so let's work it out. So let's put in 1, 4, and 7. And when we move them all, we should get the same amount. Ta-da! They're all 4. Really cool way to show how to find the mean graphically. All right, let's do the spread. All right, I said I wasn't going to do a box plot till the next one, but I might as well show you one here. This should be moved to the next one, but it's okay. So I'll just start the other one with the two-way frequency table. So I will show you how to do one of these. So let's just make up some numbers. So let's go 2, 2, 3, 6, 8, 9, 9, 11, and then we'll do 21. Cool. All right, so to get one of these boxes happen all the time. You'll see it when you're grading. But basically, you're just trying to see how spread out the data is. So all you do is you need your minimum, your maximum, your median, which we just found, and then we need Q1 and Q2. These are quartiles. This is 25% of scores. Oh, sorry, this is Q3. Medium is equal to Q2, which is 50% of the scores. And Q3 is, 75% of the scores. I don't need to write it twice. This would be 0%, and this would be 100%. Basically, we're just going to take these numbers that I made up and do what with them? We want to cut into 4 equal quarters. So how many numbers do I have? So our minimum is 2. Our maximum is 21. Our middle, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, what's 9 plus 1? That's 10 divided by 2 is 5. So we're going to cut it. 1, 2, 3, 4, 5. So 8 is our middle. All right. And now we have 1, 2, 3, 4. So what's between these? Boom. So this is 2.5. Our first quartile is 2.5. And then between these, it's going to be 10. Our third quartile is 10. Now, two numbers line, two numbers, line, two numbers, line, two numbers, line. So it's broken into equal quarters. Now, if I just did this, we wouldn't get the right answer because guess what? We want to see how spread out it is. So we need a scale. We got to go from 0 to 21. Let's go up by, I don't know, 5 every time. So 0, 5, 10, 15, 20, 25. As long as you have a scale, you can do it. So the first dot is going to be at 2. And then the first line is going to be at 2.5. So really close right there. And then the next one is going to be at 8. And then the next one's at 10. See, look, it's all bunched here and it's all bunched here. Then our final one is 21 because this is separated. Now, if we were to put this into a computer, 21 would be an outlier. It wouldn't have this point because it's over 2 standard deviations away. It would be a little outlier. There'd be like little dots here. But I just wanted to share. I'll show you, I'll do a more complete one to start the next video. All right, so the center of data set Y, I'm assuming they mean the median, is less than the center of the data. Oh, okay. So the median is less, but the spread, this one's bigger. So data set Y is less than the spread. They're both less. Let's see if that's correct. Sweet. So there's that median, there's that median. So that's the center. And then we're going to talk how spread out it is. So this is the spread. This is called the IQ range, which stands for interquartile. So our IQ range is 10 minus 2.5, but the IQ range is always just going to be Q3 minus Q1. In our case, it is 10 minus 2.5, so it is 7.5 for hours. But you can just do, it's just how big the box is. When they're talking about spread, it's just how big the box is. All right, let's do another one for fun. Let's see what we got. All right, the center of M is less than, because that's the median, because it's a measure of central tendency. Oh, and a lot of times if you're using a graphical program, right, and we got a couple of dots because they did this perfectly, they will also put a little X on it, and that's where the mean is, just so you know. This line in the middle is the median, 50% of the scores. So data set M is greater. The spread of, oh, sorry, it's less than because it's a bigger spread. Cool. All right, let's do a couple more. All right, let's find the mean from a frequency table. Isn't that fun? All right, so I'm gonna use a calculator for this because it'd be a lot of adding. They gave us a lot of numbers. So I'm just gonna go to Desmos for this one. So it's gonna be 55 times 5 plus 60 times 4 plus 65 times 3 plus 70 times 7 plus 75 times 3 plus 80 times 4. I'm not putting parentheses because Desmos will multiply before it adds. We just did 80 times 4, 85 times 3 plus 85 times 3. And then finally plus 90. This means our total is 2090. Seems a little short. See if it's still 22, but yeah, it's still gonna be 2090. Okay, it just seems small to me. Yeah, okay, cool. So now we just have to add these up. So this is gonna give us our n. So 5 plus 4 plus, oops. Let me move this. 5 plus 4 plus 3 plus 7 plus 3 plus 4 plus 3 plus 1. So it's 2090 divided by 30. So it's a summation of all of these, 2090 divided by 30. And they want it to the nearest 10, so it's 69.7. Ta-da! Yeah, I didn't want to write all this out. I did not want to add all those. See, they even put the dots. Find the mean, this is the quick method. That's what I did. I did this where I just multiplied them. This is exactly the way I did it. Cool. All right, let's find the mean giving a normal curve. So this stuff is probably a little beyond it. It's just a little bit of stats, but when we have something like this, a normal distribution, here, I might as well teach you one more thing in case you're curious about statistics. So let's say intelligence is 100, and we're going to say that it's 100 is the mean, and its standard deviation is, I don't know, 20 points. So this is our mean, which is 100. And that means if I go one standard deviation over, that's 120. One standard deviation over here, it's 80. So this is minus 1 SD plus 1 SD. And it's crazy because, ready? Is it 64%? I've done so much stats today, I can't remember the percentages. Is it 34 or 32? 32, right? 34. Okay. I was just curious. So it's 34, 14, and then 2. 34, 14, and 2. Okay. So this means 34%, 34%. So this means 68% of the population has an IQ between 80 and 120. Now, if we go one more standardized deviation over, that's going to be 60. That's going to be 140. So this is 14%, and this is 14%. So if we do this, we now know that 90, what is it, 96%? I already forgot them all. 95%. So this means 95% of people, right? So this is 95% of people fall between 60 and 140, which is kind of cool. So minus 2 SD, plus 2 SD. And notice that gets smaller because there's barely anybody who has an IQ less than 40, which is 3 standard deviations away. So you have, oh, sorry, I don't know what's up with my mouse. All right, so really? All right, so 40, 160. So this means 99% of people have an IQ between these 2 points. So this just means most people are here. It doesn't matter like how many strands of hair on your head, your height, your IQ. They are what's called normally distributed, which is a bell curve, which means more people are in the middle and less people are on the sides. So our problem for this, excuse me, on a test, it's a normal distribution. 83, a score of 83 falls 3 standard deviations above the mean. All right, so 3 above the mean is 83. And a score of 29 falls 3 standard deviations below the mean. So we need to find the mean. 29 and 83. This is a hard one. So this is 3 SDs below, this is 3 SDs above. To find the mean, I think since they're both the same distance apart, we can just find the average of this, and that's what I'm going to do. I'm doing 83 plus 29 because they're the same distance apart. And I'm just cutting it in half. So I'm pretty sure the mean is going to be 56 for this. That's going to be the middle number. Let's see. Nice. So 83 minus 29 is, what did I do? I did, I did is 56. I got 112 is the difference. I added them up and I cut in half. They wanted me to do 83 minus 29 is 6, because it's 6 away, which totally works. Either one's going to work. So let's do one that's not going to be that easy. So 3 and this one's 1 away. Okay, so what we have to do for this is 45 minus 27. And then this is what? 3 away, and this is 1 below, 3 below, and oh, they're on the same side. That's kind of crazy. Way to make it even harder. So this is 3 away, and this is 1. So this one's here at 27, and this one's here at 45. So I would do 45. I think I would add them together. I would do 45 plus 27. And this is 1, 2, 3. And this is 1. So I would do like maybe 1/4 times this. That's what my brain is doing. I was hoping to do on either side like the last one. Obviously, these are beyond what you have to know. But I just, as usual, this is what I think it is. And so that's 72. And let's divide this by 4. No, there's no way that's right. So 45, 27 is 3 below. So this is 27. And this one's 45. This is 3 away, and this is 1 away. I'm pretty sure we have to add them, and then we have to divide it by 3. Let's see what the answer is. Oh, it's just 2 away? Okay, so it's still, you just subtract and find the difference. Oh, okay, that's really cool. All right, let's do one more. Oh, wait, I need a question. All right, cool. So on a test of a normal distribution, 47 is 1 above. So here's 47, and 27 is 3 below. So here's 27. So the first thing I have to do is I have to do 47 minus 27, which is 20, and then I have to count 1, 2, 3, 4. So we're dividing this by 4, so we know it's going to be a 5 jump every time. So 27 plus 5 plus 5, or we can do just 47 minus 5. Either way, 42 is in the middle. This is a great little problem. Ta-da! Cool. All right, let's do one that's all right. So the last two on here, it's just lessons that you can look at. I just wanted to show you 2 lessons. So this module is intended for a classroom activity, and the students will run simulations and enter the sample mean they get for each student. The result is uploaded, simulates result for 5, 20, and 100 are kept separate dot plots. Students must be told for the sample size. It's just a lesson you can try. So data must clear for 5. Okay. And let's generate, I don't know, generate 20 simulations for 5 samples. Ta-da! Now, the more we do, the more it'll look like a bell curve. So the simulations is they are doing, let's do 200. Let's clear the data. Nice. So the more simulations you're going to do, the more it's going to resemble this bell curve shape. We're picking between what? We're picking from the numbers. We're picking from all of these numbers, and this is what we have. And we can change this to be 20 samples each and generate this. Perfect. And these are the values we have. So these are just little lessons you can do. I just wanted you to have an opportunity to see them. Here's another one. So students must be told which simulation should be randomizing. And we can do heights, we can do gender, we can do the surveys, do born in each month. And then like the more you do, it's it'll work, or you can just generate responses, generate 20 responses, and we'll do 5 simulations. So in case you just want to see it happen first. Hyper reasonable values for height and time. All right, so let's say they are 5 feet is 60 inches. Let's go with 65. And minutes to get ready in the morning. Let's do 20. Sweet. So there's me. And then like you can do it a bunch of them and see it. So these are they're just little ways. I've never used these before. I think that they're just good to see that you should be using your students' data. However, you want to try to gain their data. If you want them to raise hands for stuff, if you want them to write it in, this is just an activity where you can grab all their data fast. Sweet, and start it over. And the same thing for this one. Clear all surveys. Clear simulations. Sweet. So I hope this was interesting. I hope you learned a lot. I'll start the next one with a box plot and a two-way frequency table, and enjoy your day.